third and final objective for today is called resolving the vector. It's writing a vector in component form when you're given the direction angle and the magnitude of a vector. This particular problem asks us to find the components of a vector or the component form. If we know that the direction angle itself is 115 degrees and it has a magnitude of 6, so that would be a length essentially of 6 for the vector, and the direction angle starting at the positive x-axis and wrapping back is 115 degrees. Go ahead and write this formula into your note sheet. Lucky for you, this formula is very quick, and I think it goes pretty nicely. So when we resolve that vector, we're going to write it in our component form. This first thing means that it is the magnitude. Remember, sometimes it's got the double absolute value bars depending on what resource you're using. But we're going to take the magnitude, which is the length of the vector, 6, and we're going to multiply it by cosine of the direction angle, which is 115 degrees. We'll also take the magnitude and multiply it by sine of the direction angle, which is, again, 115 degrees. Then all we need to do is enter these two things in separately to our calculator. When I enter the first part in, the first component, kind of the x component that we get, would be negative 2.54, and our second component that we get is 5.44. So that is our particular resultant vector, the vector that results. Another thing I really like here is that the direction angle is an angle in quadrant 2, and this particular vector that we're seeing is one that would terminate in the second quadrant because I have a negative and a positive value for x and y respectively. Our second example features a nice picture of myself and my little brother when we were little, playing in the snow. So a child, which happens to be me, is pulling a sled through the snow at a force of 20 newtons. I had a chubby brother. So that force right there, we're seeing 20 newtons. That's the magnitude of the vector at an angle of 40 degrees. So if I kind of draw a horizontal line here, that angle that string of the sled makes would be 40 degrees. So what is the horizontal component of the force? Well, I can make a right triangle out of this to make some sense out of it and connect it back to trig. So here I've got adjacent and hypotenuse, that would be cosine. So cosine of 40 degrees is equal to adjacent over hypotenuse, and I could just multiply that 20 over to the other side. 20 cosine 40 would be equal to x, the horizontal component. And then that's just a quick little calculator function, again in degree mode, and that horizontal component ends up being 15.32 newtons. Similarly, for the vertical force, the vertical component, we can label the height of that triangle as y, and then I have opposite over hypotenuse if I pretended like I didn't just find the horizontal one. And so we would use sine. Sine of the angle inside the triangle is equal to opposite over hypotenuse. Multiply that over to the other side, and then we just enter it into the calculator. 20 times sine of 40 degrees, I end up with 12.86 newtons. Again, this connects to what we talked about on the previous slide with our formula, the magnitude, cosine, and the direction angle. Our magnitude was the force that we had, so that's 20 for each of these. And then the direction angle was the 40 degrees. Cosine always goes with x, sine always goes with y. A third example would be with Susie pulling her doll down a hill with a force of 10 newtons at an angle of 340 degrees. So that direction angle would be all the way over in the fourth quadrant, and the length of that vector would be 10 newtons, so to speak. So we're just going to use that formula that we did 2 slides ago. We've got the magnitude multiplied by cosine of the direction angle. And we also have the magnitude multiplied by sine of the direction angle. This is how we resolve a vector. We enter those two things into the calculator and we get 9.40 for our horizontal component, and we get negative 3.42 for our vertical component. So here I could label this as horizontal, and this one would be vertical. Again, this vector makes sense because this is a vector positive x, negative y that terminates in quadrant 4. Same thing for this direction angle. It terminates in the 4th quadrant. All right, and our last and final example for today would be using a little mini application problem. We'll look at this more in depth tomorrow as well. With our next lesson, which is vector applications. This one says that a 75 Newton force and a 30 Newton force act on the same object, and the angle between them is 90 degrees. We're going to find the magnitude and direction of that resultant force. So we're going to start by drawing a coordinate plane, and we know that the two forces, I'm going to start this one and label this as the 75 Newton force. And our second force that we have is 30 newtons, and it tells me the angle between them is 90 degrees. So the resultant force would be the distance from the origin to where that second vector terminates. And we need to find the length of that vector, which is the magnitude. Well, this is just a right triangle, so all we need to do is the Pythagorean theorem. 75 squared plus 30 squared is equal to that hypotenuse squared. When I simplify the left side of that equation, I end up with 6,525 is equal to that hypotenuse squared. And then I can take the square root of both sides, and that particular hypotenuse ends up being, if we estimate a little bit, 80.78 newtons. That's the magnitude of this particular vector. Then we need to find the direction. That's the same thing as the direction angle, which was our first objective today. And so that's the angle that it makes with the positive x-axis. So really it's just this angle inside the triangle, which is what we've been doing all day. We can say tangent of that angle is equal to opposite over adjacent, and then solve for theta by doing inverse tangent of y over x, or opposite over adjacent. And when I calculate that, I'm just going to round to one decimal place for this angle. I end up with 21.8 degrees. That is my direction angle. And I like to say, with respect to the 75 Newton force. And that's because I could have drawn this triangle here with the 30 Newton force along the base, and my angle would have been slightly different. So if you tell me with what respect it is to, then it's very clear to me how your setup looks. And that concludes the second lesson on vectors.